that's where the water and the gas is released. So understanding these three processes is very important. Okay, you'll keep hearing about them though. Okay, they're not gonna die on us, but we'll keep coming back. You were asked to look at the important anatomy. Okay, what are the key structures of plants? Well, we'll start with number one, that's the leaves. Okay, this picture, very similar to this picture. This one's a little more detailed. Okay, this one's a little more simplified. Okay, but at the end of the day, you know that leaves, you should automatically connect leaves with photosynthesis. Okay, it's not that plants don't grow if they don't have leaves. They have other ways. Okay, it's just that leaves are the primary place where photosynthesis occurs. Okay, that's where they got the chloroplasts. Now, how do they get some of the things? We talked about that also. The stomata. There's a word for you. Tiny little openings at the bottom of the leaf. That allows oxygen or CO2 and water to come in and out. Okay, obviously they need CO2 to start. Okay, the CO2 will come in, and then after photosynthesis, they'll release oxygen. They'll release water in the form of a vapor. Okay, and then we also mentioned just transpiration as that word. Okay, here's the stem. Again, in the back, please. Main job of the stem, support. Okay, support of the leaves, support of the reproductive structures. Some stems are actually for food storage. Okay, for example, the potato. If you're a fan of potato, that's actually a storage stem called the tuber. Okay, called the tuber. You got herbaceous plants and woody plants. Herbaceous plants, these are the ones that have non-woody stems. These are things like, your chunks of grass, flowers, things like that, and maybe not that have a green stem. Let's go that way. Okay? That green, it'll have a little bit of chloroplast in it. Photosynthesis will occur a little bit, but not by much. Okay, the woody plants, or like our large trees, our bushes, things like that have woody parts. Okay, those parts grow because those xylem and phylum, they continue to grow each year. Okay, that's why if you've ever heard of it, you cut a tree down, you cut a ring. What you're cutting, okay, what you're actually counting are the years that it actually grew, and the years that it stopped growing. Okay, xylem and phylum, two words you should know. And again, I hope you folks are on the computers. You're doing what's expected. You're showing integrity. Okay, hopefully you're going through it with me. Xylem and phylum. Here's the easiest way to tell the difference. Phylum sounds like it starts with what letter?
Yeah.
Even though it doesn't. It's a PH. Okay, but phylum sounds like. Okay, phylum allows food. Oh, sounds the same. Phylum transports food. So if you know phylum transports food, because they sound like they both start with F, even though one doesn't, okay, then you know the other one transports water, and that's xylem. I don't have a fancy way of telling you xylem with water. Okay. But so phylum, okay, that PH sounds like an F. That's the one that's transporting food. Okay. Your roots, they've got some functions here. Basically, obviously, they want to bring up water. They'll give support against gravity, against the wind, against moving water. They absorb water and minerals and surrounding tiny hairs. So you can have two types. There's the taproot, where there's one big giant root. Usually those are the things we like to eat as vegetables. Okay, and then they've got some fibrous roots that hang off of it. Or you just got the big old fibrous roots where they come from one center and they kind of spread out really tiny. Okay, these we don't tend to eat. We tend to eat taproots. Okay, you can eat fibrous roots. They're not very tasty. You can eat grass. You can eat grass. It'll take a while to break it down, but again,
My cat likes to eat grass.
You really eat it. But your roots, they obviously store sugar. They can store sugar and starch. So this carrot, okay, it plays an important part for the plant itself. Okay, when it's cold, when it gets dormant, okay, and it will stop growing, it's going to store the sugar that it can then use later when the times are better. But again, we know it'll bring up water and nutrients. The flower. Now these are just angiosperms or gymnosperms. They have no flowers. Okay, they are the reproductive part. They will vary in size, shape, and color, fragrance, okay? They're all for a purpose though. You have a specific color, you have a specific fragrance because you want to attract a certain pollinator. Okay? In fact, you go way back when we first kind of started this, that's what they talked about. Plants are smart enough that they can evolve, okay, to change something like their fragrance or change something like their color to attract maybe a different pollinator. Okay? That's what it's there for. So it's all about reproduction and production of seeds is what the flower's for. In terms of typical flower, you got your petals and your sepals. Okay, your petals. And basically when a flower is bud, so it hasn't opened up yet, that's what's being protected by what's known as the sepals. And you can kind of come down here and look at this one picture. So this is the outermost and protective layer pretty much. And then you've got your the actual leaf, the petals themselves. The petals themselves, they're colorful. They're colorful for a reason. Okay, they're telling those pollinators, hey, over here, look at me, over here, look how bright and shiny I am. Okay, come over here, you know you like yellow. All right, but other than that, they don't really play much. I mean, again, they're there kind of just for, you know, they have different shapes, sizes. The number of flower, the petals will vary. Okay. That's actually what most people like the most when they buy flowers. They're looking at the petals, how nice and pretty they are. Okay? We know that these angiosperms have both a male and a female part. Here's another one that's really easy to remember. We've already said this, but again, the stamen, it literally has the word men in it. That's the male part. Its job, it's got two parts really, it's the filament and the anther. Okay, the anther is where it produces that pollen. Some of you are not fans of pollen. Okay, right now we're in good shape because it's cold, so the flowers aren't producing the pollen. Okay, come February, March, that's when we start seeing our gardens go green. Okay, because of all that pollen that's being transported by the wind. Okay, but that's the male part is what deals with that. So the male part is what's being, you know, carried by the wind or by pollinators. Okay, the female part. Okay, the pollen needs to make it to it. So again, either by wind, by an animal, okay, by water. Okay, and it sticks to one of its parts. Remember, the female part's got a little pistil. Okay, it's got a little sticky end at the top called the stigma. Okay, the stigma is again just like a catcher of pollen. So that bee basically feeds on one flower, rubs up against the anther, gets a little pollen on its leg, comes to another. Okay, feed again, and obviously that pollen will be left behind on that new one. Okay.
Why doesn't the salmon
And self-pollinate itself? In times of need, it actually can, I think. Now, self-pollination, that's usually not really that great because it doesn't help spread the genetic information. But, you know, I would think maybe like a way that there's a lot of available. Also could do that at the same time. Both that male and female. It also might be a situation where it might not very pollen. You know what I mean? So it may not actually accept it as a pollen that's good enough. We say it that way. The other parts here, there's the style, there's the ovary. Okay, we talked about, or you read about it, that a ripened ovary, that's what you eat as fruit. Okay, it contains the seed. Okay, so every time you eat a strawberry, banana, okay, you're eating a ripened ovary. Yeah. Talking about pollination. This was something that was supposed to be included in your brochure. Some of you, a lot of you, this is probably the most missed part. The pollination cycle, things like that, that was what was glossed over by a lot of you. Some of you also didn't do the garden, which I thought was the easiest part, to be honest. A lot of you glossed over this in terms of pollination. I know we didn't, this is probably the least amount we saw. They talked a little bit definitely in the mystery. But so you got your, basically the flowers pollinated when you got your pollen, reaches that stigma. Now you're basically the male part, the sperm cell has now made the egg. It can now go down into the ovary. Okay, it starts germination. The zygote is now what happens when you have male part and female part. Okay, with the ovary sperm. Okay, they can actually start the fertilization process. Okay, now you basically start the development of a seed. Okay, and then they continue on from there. Pollinators. Again, most angiosperms rely on pollinators to transport their pollen from flower to stigma of another. Again, we've already mentioned this, the color, shape, smells of the flowers, those are designated for that pollinator. Okay, they're not looking for you basically to pollinate just any old flower. Okay? You want to look for something specific. You've got birds, hummingbirds, bees, wasps, bats, flies. Okay, here's what they're looking for. Gave you a little breakdown. We don't ask specifically, okay, hey, what kind of color a hummingbird's looking for? No. Just have a general idea. We know that things like birds, bugs, things like that can pollinate. The seed itself, okay, talks about the idea of structure that contains obviously the young plant inside. Okay, there are ways to actually feed it before it can actually start making its own photosynthesis, food. Okay, inside the embryo itself, okay, we know those are found inside of fruits sometimes. Okay, when a seed hits the ground, that does not mean it's automatically going to start to grow. Okay, it needs certain factors. Okay, in order to start germination. And when it starts to germinate, basically it's going to take the water from its surroundings. Basically what happens is that the inside part gets too big, and then it basically expands outside. And when you actually start seeing root popping out, that's because it's got large enough it can't stay inside its little casing. Okay, some of us like to eat seeds, corn, for example. Okay, beans, green beans, those are all different types of seeds. Okay. Sunflower seeds, exactly.
Yes.
Okay, so you're actually eating seeds yourself. Last thing here is plant tropism. That's just a response. Many animals respond to stimuli just by moving. Okay, if I just turn the lights off for a while, there'd be a time when you get tired of it, you probably just leave and want to go to the light. Okay, or if it was just too cold in here, you leave because you want to get the warmth. That's tropism. Okay, that's you responding to stimuli. Plants do the same thing. But the problem with that is, can plants move?
No.
They cannot just get up and start walking.
That,
Okay, so if the light, okay, which maybe started coming in like this, okay, and I'm a happy plant, I'm growing, now it's being blocked by something else, so they built, or they put something in front of it, and now the light can't come to me. Guess what the plant is going to do? It's smart enough, okay, to actually start growing around to reach that light. The light will hit it. Okay, and that's what's called tropism. And again, there's three types. Light is one of them. So when you kind of see plants kind of growing in weird fashions to get to light, that's light photo, or what's known as phototropism. There's pigment tropism, which is touch. So if you ever, and also with gravity too, but tropism, when it's touching something, it doesn't light. Or if it's looking the idea, if it's touching an area and needs to look into the water, something like that, or it needs that support. If you're trying to grow, a lot of trees that you purchase, they come with this already. Kind of got that support already there. Sometimes gravity will take effect, and you're trying to grow like a vine, grapes. Okay, they grow on a vine. So you want them growing up. Well, gravity doesn't want that to happen. It wants you to grow down. Okay, so you can take it down to accommodate. No, they can't.
They have to just go like.
They can't uproot themselves and just start moving. You get a little support. Now with the fall.